Hello, hello, and welcome everybody to Utah Zig. This is for the benefit of the recording, of course, because you all said this 3 times. But we're going to have a wonderful night tonight. Welcome to the world's most unsafe meetup, especially when it comes to memory. And thank you to Vivid for hosting both the place and the pizza. And thank you to this powered by Andrew Gossage presentation by Andrew Gossage.
So, hello everybody. We're going to talk today about doing web dev in Zig, but first I want to kind of introduce myself. Most of us have already, I've met almost everybody here, if not, no, I've met literally everybody here. But for the purposes of the recording, my name is Andrew Gossage. I'm the director of software engineering for a company called Gen AI Learning Solutions. We build AI tools for college professors primarily. I'm a programmer. I've been programming since I was 11, which is the same year that Git came out. I am a nerd. And
Why were you more sure about that one?
and, you know, there's different people mean different things by that. And then I suppose I'm an okay guy. So for my work, I do work primarily with web technologies. My kind of claim to fame is that at the last 2 places I have worked, including this place I work now, I have convinced them to use at least some Zig in production. So that does make me your king, as this is a Zig meetup.
Thank you. That is true. I don't think anybody else can top that in this room right now, today. But you're working at some place. Actually, Niles may have you because he works as a Zig engineer.
Oh, where do you work now?
TV Scientific, don't tell Andrew Kelly, but yeah, that's where I work now. And the whole code base is split between Zig and Python, because it's mainly machine learning stuff.
Okay, well,
We're streaming. Your PRs are never getting merged now. I don't know.
I'm sorry, Andrew Kelly.
We'll cut this part out.
I take it back. The king is dead. Long live the king. And then I want to kind of keep this kind of loose and formal like we always do. There's some things that I want to touch on. And then I have written a web server in Zig, and we'll take a look at that. It's actually the second web server I've written in Zig. The first one I wrote before there was a standard HTTP server built into Zig, and it was very bad. But now I'm using the standard HTTP functionality, and it's a lot less bad. So first off, when you're talking about doing web dev, there's certain paradigms that you can work in. And really, a lot of the choice, at least how people will look at it, is there's an easy way to do something and there's a hard way to do something. And usually the decision is to do it the easy way. Unless you're Niles and then you rewrite your compiler.
Yeah. I feel like this is very difficult because, you know, when they show the background is red but the word is blue on the one, and then the background is blue on or red on the other but the background's yellow, I feel like that's what's happening right now. Low level is the easy way, high level is the hard way.
Why would you say that high level is the hard way?
Well, because then not only do you have to deal with all the low-level stuff, but you have to deal with somebody's abstractions over top of it that make it work differently than the way that it works naturally.
You know, thank you. We can now conclude my talk. You've come to the point that I was going to make.
Oh, sorry. Sorry.
We're interrupting too much. Let him cook. Let him cook.
I didn't know your name was Andrew Gossage. Let's go to the last screen and just work.
I've only got 5 slides or something like that, and he's jumped all the way.
The twist has got to be on the next one. So we're pumped.
So I think that's a really good point. Like people's versions of abstraction to do like the high level, that can be as hard sometimes as programming.
Oh, I will give you a perfect example of when. Okay, actually, now I'm getting ahead of myself. Let's go through some of the reasons that people might be inclined to choose kind of high-level programming paradigms for web development or low-level. In high-level, a lot of times you have dynamic typing, so you can build things quickly. You have garbage collection, so you don't have to worry about memory management. These programming languages are often interpreted, which does come with its own benefits. You've got things like Lambda that works really well for interpreted languages, but not very good for compiled languages a lot of the time. And as we talked about earlier before we started, the perception is that deploying something to somebody else's computer is going to always be a lot easier.
Just vibe code it.
Just vibe code it. And vibe coding does not often work very well with low-level programming languages. However, with low-level programming languages, you can run things faster. Static typing, so things break a lot less of the time due to typing errors. And because it's compiled, that's kind of just a repeat of the fast. Hopefully, compiled languages will run a lot faster. That is actually not purely true, but there is the opportunity for that to be the case.
So are you talking about specific languages, like the Java web servers, the Golang stuff?
So it can be languages. There's also more high-level frameworks and more low-level frameworks. And going back to the point about the extractions and how abstractions can actually be harder or can bite you in the butt, let's talk about JavaScript for a second. If you're coding in JavaScript and you're coding a server, almost everybody's going to choose Express, right?
Yep.
And that's a really good option for a lot of things. It's very fast to get going. The documentation is superb. If you want to set cookies, there's a library to set cookies. If you want to read the input that's in JSON, you can just read the JSON input. If you want to read formatted input as JSON, it just does that, and you don't have to worry about it. But then, what happens if somebody sends you a web request, you respond to it, and then there's something that you need to have happen after the response goes out? This is not that odd of a situation. It actually happens fairly frequently. And so what you will end up doing a lot of times is either setting up another async task to run, which requires like 3 different JavaScript libraries just to get the super basic thing, or you'll have some microservice somewhere else that you then call to have execute the task after you finish responding. Whereas realistically, if you were writing your own framework, you could just control what cleanup tasks or scheduled tasks happen after the response goes out.
In what way do you mean? I mean, like, in that example, I just used process.nexttick.
So, but that is something else you have to bring in. That isn't something
Well, it's built in.
into Express.
Well, it's just built into Node. It's just part of JavaScript. It's not even Node. Well, no, it is Node. JavaScript has set immediate, which is only slightly different than nexttick.
Okay, well maybe I'm missing something, but
Anyway,
a different problem that you can run into with bringing in somebody else's abstraction is, for instance, at work we have a single page application, and our primary front end is a single page application, which generally speaking you want to bring in some kind of router instead of writing your own. That's generally the solution people will come to, or they will just write a very basic one themselves. But so we used Svelte, and we used Svelte SPA router, which is an extremely popular router for Svelte. But then when Svelte migrated to from Svelte 4 to Svelte 5, the router did not migrate.
It's okay, AJ, you code and go now. You don't have to think about this anymore.
Thank you.
And, almost a year after the tech spec for Svelte 5 was released, it still doesn't work properly. You can use it in Svelte 5 compatibility mode, where you're really just writing Svelte 4 with Svelte 5's compiler, but then you miss out on a lot of the functionality. So we've ended up we are now writing our own router now, which would have been easier if we had done that before than having to do it later when we relied on that router. Because there are no good routers that are compatible with Svelte 5 that we've been able to find. So we made the easy choice at the beginning, but it turned out to not be the easy choice once we needed to scale up further and move faster. And so it actually would have been the easier choice to make the harder choice earlier on.
But who knew?
Who knew?
I didn't.
Well, no one did, or else they wouldn't have made that choice.
If somebody's on version 4 of their library, you should probably not go anywhere near it. Because version 5 is coming, and 6 after that.
Yeah, I mean, Node's on version like 22.
Well, but that's different. It's not, Node is not doing breaking changes to their APIs. What I'm saying is when some framework author has a library, they're not increasing to version 3 because, oh, oopsie daisy, there was a bad handling of a parameter and we had to change it from a string to an int, and that will break some number of programs somewhere. It's like they redesign the philosophy of it from the ground up and keep one or two of the function names similar. They're writing a completely different framework and then calling it the same thing and giving people this false belief that they need to upgrade for some unknown reason.
I mean, on the other hand, talking about Zig, right, I remember when I did write my first web server in Zig, it was like a few weeks later, Andrew Kelly went in and rewrote the entire TCP stack. And it was a minor version.
Well, it's V0, so
yeah.
Minor is breaking and patch is minor.
Yeah, but I just don't think you're going to be able to escape that. I don't know that you can foresee that.
Have you heard of our code in Savior Go?
I have, and there are valid reasons to not use Go as well.
Oh, sure.
The same thing happened. Like, I did Go servers like 6 years ago, and the ecosystem's completely different. Like, you can still run the code, it still works, that's fine, but there's been so many ideological changes and stuff. We had a situation in Flutter, same thing. We upgraded to a package, and like some basic component that was a Flutter component, like, it didn't work anymore. So it's always a risk. This is always a risk across more than just web servers.
Well, I mean, since Go has released 1.0, I mean, I'm not trying to hijack the meeting to be a Go, Go. But I want to defend Go. Like, since declaring 1.0, the only breaking changes they have made have been in the build tooling. There have been no language breaking changes, and they even track syntactic sugar changes with the version number in the Go mod file. And I believe that they were doing that. I don't know if they introduced it all the way back 6 years ago, but Go code that compiled then compiles now, and maybe some crazy person in the ecosystem writes some module where they rewrite the whole thing and do the reactor Svelte type of thing. But the Go standard library does not They changed the random number generator, and now it's /rand/v2. The original one, they do not break the standard library. It is law.
So the Go, as a programming language, I'm not a Go developer. Go is extremely stable, though.
Yes.
And its standard library is really good.
Yes. And I hope that Zig will, I believe that Zig will get there. I think once Zig hits 1.0, I don't think that we're going to have to worry about things breaking every other weekend.
But the fact of the matter is, people do use external libraries in Go. They do not only use the standard library, and then they end up with the same problem anyway, because you can't guarantee that whatever libraries you're importing are going to be as stable as the standard library.
Yeah, I mean, like, if you're going to write Go code, you shouldn't rely on other people's libraries, because the Go authors already gave you literally everything that you need to do anything.
I don't disagree with that sentiment, but it's not about. But that's not realistically going to be how everybody or even the majority of people program.
Sure, most people don't read the documentation. I agree. No, but anyway.
I mean, and the point of my talk is write it yourself instead of bringing in external tooling.
Yeah, especially with AI these days. I mean, AI's maybe not as good with Zig, but... What? I'm just laughing.
So, now that we've come to the decision that writing it yourself, now that AJ has made my point for me, that relying on external libraries is not the way to go, let's talk about...
Wait, can I argue for external libraries?
No.
As someone who's in these programs.
Absolutely not. Go ahead.
Okay. So, outside of coding, a lot of people think of coding as just like that stepping stone or rung up the ladder that you need to get through to get to the thing you need to do. Like in medicine, there's a lot of horrible Python code there, but it's just because this library, even if it takes like 4 seconds, just gets the job done. And that's all they care about. That's like it. And that's why they like yeah, exactly. That's why they like high level. So that's my argument for high level. Not saying I don't like low level. I'm just saying that's why people do high level.
So you're saying it's very easy? It is very easy.
Exactly. It's like slapping a Band-Aid on a wound. Like, you know the Band-Aid's not actually curing the wound, the person is, but it just like helps covering up and
So,
smooth it over.
my dad is a programmer, and my dad professionally programs in, it's not his primary job, but he programs in Visual Basic. And he has been writing the same Visual Basic code for the last however long Visual Basic has existed, essentially.
That's what's used in Excel, right?
Yes, that is
Yeah.
kind of what's used in Excel. That's VB script, which is like a dialect of Visual Basic, essentially.
Because technically, the number one programming language in the world is Excel. Because there are more accountants than programmers.
Yeah.
Are there?
Yeah.
Not in Utah.
Not in Utah. in the world, yes.
Okay.
But, I mean, there are so many things my dad cannot do, essentially, at his work, because he's been dedicated so long to using the easy thing to use. And at this point, if he wanted to migrate to something else, it would be extremely difficult. So that choice, that slapping Python on it,
Yeah.
I used to be a Python developer professionally. I spent years doing web development in Python, and eventually you always run into a scaling issue. You always run into a scaling issue when you're running Python. The same thing happens in JavaScript, not as quickly, but that's why serverless functions are so popular, because you cannot scale JavaScript vertically. So, no.
Well, I think, okay, I think that the problem that's being solved is marketing. The problem that's being solved is, it's not solving a technical problem, it's solving a marketing problem. So people want to know, how do I do more than one of these at a time? And companies put lots of money into marketing lambdas, functions, whatever, because they have really, really high markups on it, and that makes it affordable for them to market it. And so when people look at how do I run more than one of these at a time, they come across that. But it's not a simpler solution. It's just one that is more, it's like, okay, like we all in this room know why we don't use PHP, right? But if you are someone outside of programming and you don't know about programming, when you first start searching about programming, PHP is going to be the top of the list. And you're going to believe that PHP is what programmers use.
Yeah, so I don't disagree that it's not actually easier, but JavaScript is very difficult to scale vertically. It just is, and it is single-threaded, and there are some workarounds to that. I do know that.
Well,
but
I'm not arguing that part. I'm just saying that functions don't actually, like Lambda is not what solves the problem. What solves the problem is running multiple processes.
Yeah, but that ends up going to Lambda, or you end up working in Kubernetes.
Or you just pay $5 a month on DigitalOcean.
I mean, you could do that, but I'm not talking about what people... I'm not purely talking about what should happen or what could happen.
I get it. But that's all I'm saying is that I see it as it's a marketing solution. It's not a technical solution. It's not technically like, oh yeah, this is what we need to do. It's marketing. It's like, this is what we've been told.
It is a legitimate, whether it is the best solution, it is a legitimate technical solution to an actual problem that you will encounter if you choose to write something in JavaScript.
Agreed.
It may not be the best solution, but it is the one that feels the easiest. Whether it really is the easiest, it feels the easiest.
Agreed.
And that's what people go with. And that's what I'm saying. These problems you get when you do things the easy way, or what you're told is the easy way, is you always end up with scaling problems. And in Python that happens essentially immediately. In JavaScript it happens 3 months later, but you always end up with those problems.
So my argument that I want is a little different from your argument, is that if you're just starting out and trying to make sure an idea works, why not rush it through Python, just rush it down through Python, check that it works, and then go back the hard way and scale it out.
That is...
People never do that.
If
They're stuck in the technology and they're always trying to.
If you look at, so astronomers have to run these crazy mathematical calculations, and they still do it almost exclusively in Fortran. And that's because their college professor wrote Fortran code in the literal 1950s.
Hey, don't make fun of MATLAB and Fortran.
So instead of writing something good, they just repeatedly patch the same code that is older than my parents.
And there's no documentation for that stuff, and there's no way you can replace it.
Yeah, that's the same with Cobalt with banks, and that's the same with airplanes and whatever they're
Yeah.
doing.
Fortran actually has some of the fastest math libraries, though, so there is actually legitimate reasons for using it.
There are, but I don't think... Yeah, anyway, that's a side topic.
But,
Yeah,
Blazingly fast.
blazingly fast. So,
So did you
I would love
investigate
to know the next
Fortran
slide,
web
sorry.
servers?
I have actually investigated Fortran web servers in the past. There is such a thing. There is also COBOL web servers. That is, somebody wrote a COBOL framework called COBOL on Wheelchair.
Nice.
Not in a jokingly way, right?
I mean, it did work. So, but yeah. But you could, so in reality, you can solve almost any technical problem with almost any technical tool if you are really dedicated to doing it in a specific way. There are people who have written roller coaster simulators in Excel. But just because you can do something doesn't mean you should. And similarly, just because something's easy doesn't make it the right way. Also, because something's hard, that doesn't make it the right way. That's also true. Like writing COBOL, extremely difficult, not going to reward you with fast performance.
Unless you have your own mainframe.
Yeah, those are expensive.
It's surprising what you can virtualize faster than you can run the native way. Like the Switch 2, running Switch 1 games.
That's true. Or Linux running Windows games. They run better on Linux than on Windows. Okay, so now that we've decided that we're going to not pull in any external libraries, we're just going to do things ourselves using the standard library.
I mean, it's a little different Zig because Zig is growing.
Let's look at some of the problems that you have to solve yourself if you're going to write a web server. These would largely actually be the case even if you were writing your own Python server, except you could bring in other people's code to solve it. So let's look at what happens, like the overall process from 2,000 feet in the air when you want the web server to web serve. First thing that happens is a user sends a request. That can be JSON, that cannot be JSON, but they send a request. We need to be listening to the request, so we need to listen to a port. Thankfully, Zig just handles this part. You can handle it yourself. That would be going further than I would go in the quest for low level, but you can do that. Then you need to answer the question of load balancing. And there's a lot of strategies for doing this. Lambdas is one strategy. Multitasking with thread pools is another strategy. The way Node handles it, in case anybody doesn't know or is curious, is Node is purely single-threaded. So
That's not true.
no,
The main execution thread is single-threaded.
that's what I meant. The main execution thread is purely single-threaded. You cannot readily have multi-threaded code in Node, and that includes the web servers. So unless you're using a tool on top of Node, the way you handle multiple requests at the same time is you take one request, then you wait till it does something IO bound, and then you pull the next request, and you switch back and forth based on whether or not you're waiting for some IO to happen, which is faster than running the entire web request and then running the next web request because IO is one of the slowest things. But it's still not as fast as true multi-threading. Once you have these requests, you need to determine how they go to the functionality that will actually serve the user's needs. You need to do that, you need to handle input from the user, and by that I mean you need to parse the body of the request and query parameters. And the body of that request will often be JSON encoded, but there's actually a lot of different encodings that it will occasionally be that you might need to factor in. You need to handle some sort of request to your database or to some other APIs or microservices if you're forced to use those. You need to send a response. And then there's some cleanup that needs to happen. You need to clean up the memory. In Zig, you largely have to clean up the memory yourself. there might be other tasks you want to schedule with it. So these seem really complex, but really they're not. There's a lot of things to take care of, but they're not as bad as they initially seem. And so we'll look at the code for a web server written in Zig, but actually first, here is a web page hosted from Zig. And this button sends a post request to the server, and the server counts up a number. Super simple. Thank you.
Is this local host, or are you actually going on somewhere?
It is localhost, however, if I go to
Visitor net.
Yep.
Okay, you're on.
Now I need to sign in. Oh, no, there we go. And here we have an actual website live on the internet served by Zig. And there's my beautiful face.
That is beautiful.
So let's look at some of these things. So actually, let's go. So this is not going to be the absolute simplest way to do things because I am handling things like body parsing and query parsing, and I do have a callback based router. But this part right here that you see in that function, in that init function, is how you just initiate a web server in Zig. It's super straightforward. You just standard.net.address.parse IP4. You give it the address and the port that you want to listen to. So in this case, it's going to be 127.0.0.1. That's localhost. If you were going to listen to an external port, it would be 0.0.0. There's 4 zeros. And then the settings.port in this case is 8081, but it can be, there's literally thousands of ports you can choose from. Not all of them, some of them are taken by other things, but just for information's sake, the default port for listening to incoming HTTP traffic is port 8000.
Why are the defaults that way? Like, where's the 127 come from? Is that like the maximum value of an ID or what?
I honestly have no idea.
127 is local, and then there are others for other values. And then
There are.
0.0, 0.0.
The 0 and then everything is for external traffic. There's also ones for local traffic. 127 is for your own machine and not other local traffic, but I don't know where those specific numbers come from. The 0 makes sense because it's like, that's not some subset of the internet, that is, you're listening to the internet, but
All zeros is shorthand for don't bind to any specific address. You can give it a specific IP address, and you get multiple IP addresses, and typically it'll bind to that IP address. And then if you do, 127.0.0.1, that's a standard local host, so that just binds to the local host, which means that nothing from the outside can get to the server.
yeah, what we're saying is we don't know why it's 127 in particular rather than
Because
128.
the 127 block is reserved for local host.
So somebody made a decision.
If for the same reason that 10 dot whatever is all private IPs and 192.168 dot whatever is all private IPs and 172 dot
No.
16 to 172.31 is all
Yeah,
private
yeah,
IPs.
yeah. And
They're all just assigned blocks of IPs, so the
And-
127 ones are all local host.
do you know your CGNAT?
100? That's tough, I don't know. It's not all the 100 blocks.
I think it's 100.7. I don't remember either, but I found use for it.
Yeah, we We are strongly considering using it for a few things because we're running out of private IPs.
Yeah.
Okay. Let's look at like the simplest sort of load balancing we could do for this server. And that is we're going to spawn multiple threads. We're not going to use any kind of advanced message parsing. We're going to listen for the state of the threads but the traffic only needs to be one directional, so it can literally be just a pointer to an enum where the different workers can set that value of an enum, and they can set it to be an error if they errored, and you can do that with error defer in Zig. So before the thread kills itself on an error, it will tell the master worker that it needs to be respawned. And luckily, spawning threads in Zig is super simple. And if you were doing a more complicated setup, there are more complicated strategies for message passing. Like if there was some reason that the different workers needed to pass threads to each other rather than just some main thread listening to the status, you would not want to use that setup. But if all you care about is detecting what the workers are doing, then this works just fine, I would argue. And then we're sleeping between polling, so we're not just constantly polling and spinning. And then this is the function that's going to be run by each of those workers. It's going to listen for incoming traffic on the port. It's going to update its state. This receive head is where you actually get the incoming traffic. Go ahead.
Okay, I got two questions. One is, how do you decide how many workers to use for this? And then two is, for the message, like what if someone's like just malicious and says, I want infinite resources? How do you handle that?
That's an advanced topic.
Oh, okay.
So I will address very briefly how many workers you have. There's a lot of different ways that people will calculate that. With heavier workloads, a lot of developers will say you never want more workers than you have CPU cores. But that's honestly a subjective decision. And a lot of times the only way you're going to know the right number is by actually doing testing.
Well, and if you're doing something like this where you're not using some sort of I/O ring or async thing, then you basically you want as many workers as your RAM supports. I think it's 2 megabytes per thread or something like that. Is that right?
I don't remember.
Yeah.
But yeah, there are some reasons why you would still want to limit the number, but you could get away with quite a few, especially if you're running a machine that all it does is
Just this.
this, yeah. And yeah, I mean, and Zig can spawn thousands of threads, so. Which is one of the reasons why Zig is not going to encounter a lot of those vertical scaling problems. If you find for some reason that you are not serving web requests faster, you can just increase the power of the machine you're running it on, or rather run it on a more powerful machine, give it more resources, spawn more threads if you need to. Whereas something like Node or Python, at some point, it's not going to matter throwing it at a more powerful machine. It's just going to stop scaling vertically.
Yeah, and one thing that a lot of people don't realize, because, for example, Lambdas, this is part of how they make their money, is you only have one thread, like you only have one thread on a Lambda, like they bind it up so that you can't, so whether you're using Zig or you're using Node or you're using Go, you effectively get the same performance on Lambda. I mean, that's not entirely true, but that's one of their tricks of how they get it, right? If you are deploying something, you want to deploy pretty much always with at least 2 cores, because no matter what platform you're using, there's typically some sort of background thread that's managing something like garbage collection, disk reads, web requests, like something like that. So if you were to deploy single-threaded Zig versus JavaScript on a single-core VPS, JavaScript will kick its pants all day long. If you deploy to a 24-core VPS node and Zig, then you're gonna, and you're no longer limiting Zig to a single thread, you're gonna be able to extend Zig to use the full CPU resources, whereas JavaScript is only gonna ever be able to use, maybe it will be able to max out 3 cores on its like best day under ideal conditions.
Yeah, and there are things like PM2 that will run multiple instances of Node on a single computer, and then load balance between them. But then you have the memory overhead of every single instance of Node you're running. So even under that circumstance, you're not going to get as much out of it.
Yeah, and the garbage collection can be quite intense.
Oh yeah, so if you're looking at, like Python is even worse, but Node is similarly bad. Every single line of code, there's a chance that the machine decides to run the garbage collector. So for every single line of code you run, there could be hundreds or even thousands of lines of garbage collection logic that can run. It can get quite insane.
But generally speaking, if you run at least 2 cores, you will get the benefit of some of that background.
Yeah.
So right there, you're kind of, you're listening to the port, you essentially reserve it until your total communication, and you're defining your buffer size for how much is there. You read it and you're sending it on to the server that's going to handle the message.
Correct. And this didn't used to be the case, but in Zig, this server object is per connection. You would think of it as being, in a lot of other languages, it's like you have a server and then that's all your connections come from the server, but it doesn't work exactly like that in Zig.
So this is allocating a copy or a new instance of a server, or?
So there...
Because it's using a thread model, so one server, one client, one server, one client.
Correct, essentially.
Okay.
And then we then need to decide where the traffic goes, and I have a very simple router. And, oh, here it is. So there's some list of routes, and actually we'll look at that. So these are the routes that I've set up here. There's a path, which is a string. There's a callback, which is a function. And then there's a method which defaults to get, which is the standard to have everything default to get in most servers. And so we're registering callbacks, like here's like a generic post endpoint where we're returning just this junk message back. But the way that we're going to match to the correct router is we're going to iterate through those routes, and oh, here it was. And then we're going to use a tokenizer.
It's not optimized.
Yeah, it's not optimized.
It is very much not optimized. But you know the great thing, this is the point of my talk, guys. If you don't like the way I did it, I encourage you to write it differently. But essentially, a path on a website is an array that's linked together by slashes. You need to split it up somehow and traverse it and use some kind of logic. Generally speaking, in a lot of servers, the way you have variables as part of that that URL is you register the URL with some name that starts with a colon, and that's how you know that that's a variable rather than a string that it actually needs to match to. And then I also do support asterisks, so if you want some kind of subrouter, you can just say, I'm going to register this function, and anything that starts with this and then has an asterisk, send all of that to me. And then I'll handle that.
That's great.
Yeah, and it works, and it's just a few lines of code, and that's enough to go. Honestly, this is not that much more lines of code than you need to get a router going in Express. And
Did you compare speed to Express, or did you look at
Oh,
this is so much faster.
what? Yeah, you got the threads.
The only reason I ask is because, isn't there, what's Zig's version of the bun? Does bun,
Oh yeah, so
why use this custom versus bun?
so
It's in apples and oranges, or more like apples and turnips.
And then one other question.
yeah.
On your return, are you sending like just a string body in here? I missed that. Or do you have somewhere else like an index.html that you're just reading, loading, and sending out?
I'll show you. So if we go to routes, the way a response works, all web requests work by just having a very long string, and then you've got headers and a body, but the way that's encoded is just the headers end when there's a double return. And then everything after that is a body. So if you want to send back JSON, you just encode JSON after a double return in the headers. And
What does the double return look like?
/r/r. Yeah, just the ASCII
Wait,
return.
Is that Linux dependent, or is that on Windows like?
No, that's
That's HTTP.
That's HTTP.
HTTP. That's the standard.
So this has structures that define all that, right? So you don't actually have to do all that parsing yourself.
So you do have to do that parsing yourself.
You're just getting a request, and that's everything that's coming in the request.
Yeah, and Zig will not parse the request.
Parse-
Zig will not parse the request. So I have to, in my web server, I have to parse the request.
So same thing when you're building the response, you have to build the whole thing.
Zig will take a string and take headers and then build that much for you. But honestly, that's not that useful because, again, it's just one long string. You could easily just build that one long string if you felt like it.
Right.
Okay, I have two more questions now.
Yeah.
One is, how do you know the message got fully written into your buffer? Is that just automatically handled by Zig, or do you?
Yeah, so Zig does handle reading in all of that, and it handles that logic.
Okay, and then the second question is, when you send a response and you're waiting for another input from that same location, or you're not looking at that, you're
So-
evolving code.
So the standard so there's a protocol in HTTP where you put a header and it says keep open, and you either put true or false. Headers are essentially key value pairs.
Okay.
And you are supposed to default to keep open true. So you're actually not supposed to close the request. You're supposed to listen again, which I am not doing. I'm responding in the headers saying that I'm not going to do that, which you can also do.
So with the communication, you're allocating a buffer. So essentially, you don't have anything that's actually checking how big the request is, so you don't get a buffer overflow, right?
Yeah, so you allocate a buffer. You are not going to get a buffer overflow in Zig, essentially. It is smart enough to prevent a buffer overflow.
You're passing in an allocator with the
What?
read buffer, right? So that's why you wouldn't have to worry about that,
Yeah.
right?
Yeah, so you're not going to have...
So if they pass in more, you get a truncated. whatever
Yeah, and
they
then you
pass
can-
in, and then you can determine, hey, that's not gonna be right.
And then you
So
can-
want JSON and
Yeah,
expecting what body parameters.
And then you can read again.
So that handles malicious attacks gracefully.
Yeah, Zig will not write past your buffer here.
Okay, wait, which line are we talking about?
This is the stuff that was before.
Yeah,
Oh, okay, sorry. Because I thought we were talking like, I was looking at line 76, I'm like, well, it's just gonna read and it's just gonna use the allocator.
yeah. So this isn't reading. This is the response right here.
Parser, JSON.
Yeah. So this is sending it to my JSON parser, which is just the Zig parser, except I am finding, because Zig does have a built-in JSON parser, but it will not find which part of the HTTP request is the JSON. So all I'm doing is finding where that JSON starts, which is super easy. You just look for an opening squirrely bracket, and then for the end, you look for a closing squirrely bracket, and then you just give the Zig parser everything between those.
Unless someone's done something weird in the
Oh,
header.
is there not a streaming parser presently?
I think there might be.
Did you say streaming parser?
Yeah.
Yeah, the JSON one that's in the standard library, it can go one byte at a time, I think, right?
Yeah, but you're gonna need to give it where to start, because if you give it the entire request, it's gonna try to parse the headers, and the headers are not JSON encoded; they are URL encoded, and you will throw an error.
Will you highlight the line that we're talking about?
We're not talking about anything that, I mean, for reading the body.
So
This is here.
This is reading the body. Post input.
So what
That should. Yeah, explain.
So that request has a read buffer in it. And so that's that last parameter, is the read buffer. And that's the body of the HTTP request that's sent. Well, not just the body, it's the body and the head. And then I'm giving it a type, which is going to get fed into the Zig JSON parser. Zig's JSON parser can actually parse to a non-type safe object where it's essentially a hash map. Or you can give it a type and get a type back, which is what I vastly prefer.
Right.
And then I'm giving it an allocator, so it'll use that to allocate the object.
So post input is the type, right?
Yeah, post input is the output type of that call, yes.
Yeah. Allocator is what it's going to use to read in the read buffer.
No, so the read has already happened at this point. The read has already happened at this point. That's what it's going to use to allocate the post input.
Okay. So all right. I'm sorry. I missed something fundamental while I was.
So what we've gone through is that he gets the message from the port, and then he showed a little bit about the routing. So use information from the header to actually do your routing stuff. Then he's got stuff in here that pulls out. We've read the request and divided it up, and now we're pushing out a response based off of.
Well, where I'm confused is this says standard HTTP server request. That's the request object. So what I am used to is that a request object would have the headers already parsed as part of what the.
Zig does not parse the headers for you. It does not separate the headers from the body or divide the...
Then what makes this an HTTP library rather than a TCP library?
There are a lot of things required in the back end to accept things that are formatted for HTTP, but this is like as thin of a wrapper around TCP as you could possibly get,
This is from
essentially.
scratch, so it isn't a framework that may be doing that for you.
Well, but it says standard.http.server.request, right?
Yeah,
That's where, if it's going as far as to say what is a request, well, it has to, in order to know what the boundaries of a request are semantically, you need to see the method name, and then the path, and then the HTTP version. Then you need to read to the header where it says either content length or chunk, and then that's how you know how much you're going to read. And that is something that I've never seen a module called HTTP that doesn't have the functionality to read the length information of the buffer.
So it does have the length, but it does not divide. So that read buffer and that request, you have to figure out where the headers and the body begins. It doesn't go that far. It does extract out the endpoint that it hit, like the URL, but it's not going to do, essentially any existing library is going to handle that for you, but this isn't an existing library. This is just a minimal example of writing your own server. And if you were going to write a server in basically any programming language, you would have to do a lot of this stuff yourself. But
Well, if I was using a TCP library, yes, but if I was using an HTTP library, generally, well, I've never seen an HTTP library that doesn't provide a mechanism to parse the headers and to give you
parsing the headers would require allocation, hidden allocation potentially, which is why it doesn't do it.
But is there not like a what I would imagine, and maybe it's just not there yet, but what I would imagine is there'd be a standard.http.server.request.read headers, and you give it an allocator and it hands you back typically just a map where there's a string key and then there's a string, a slice of strings. Sorry, what do we call it? What do we call variable arrays in Zig?
Array
A
list.
array list.
Array list. Okay, thank you.
So
Could we look at the definition of request? Do you have to go to
Yeah.
definition functionality?
Just so you can see what functions are in there. What it's doing.
oh
I think you did it on
You did
standard.
STD. Can you go back,
yeah.
highlight request?
By the way, what editor are you using?
Neovim.
Okay.
Yeah, he's a hype chaser.
Mine,
He watches the Primogen and just does whatever.
I do watch the Primogen.
Primogen's pretty awesome.
Yeah, I love the Primogen.
Okay, so it might have changed. I wrote this back in like the beginning of 0.14, and it still runs under 0.15, but
I think they may have changed updates.
Yeah.
Since then.
Okay, yeah, I mean, it makes sense if they just haven't gotten that far yet. I totally understand. that is not typical behavior. I don't even know how you would track what a connection is if it wasn't reading that
Wait,
information.
it has a head start.
Yeah.
Yeah.
What you were talking about?
yeah, it didn't used to.
So the head start just pulls out the data for you in the head.
So this
Yeah.
is the stuff they were talking about, because I think a lot of the Zig frameworks were actually using other, like C, HTTP systems to bring stuff in.
Okay, actually no. So this is the head object, and okay, it does have a parse method. now.
Okay.
So-
Oh, but it only works for 1.1 and 1.0, so nothing for 2 and 3.
Yeah, and this
Well, yeah, that's pretty common, because 2 is a different protocol. I don't even think there's shared code between the two.
So the actual bodies will look the same, but how you interact with everything is entirely different, and it natively supports splitting things up, whereas 1.1 and 1.0 do not. So this didn't used to be here, so I was spouting a little bit of outdated information, but this server is only like 3 months old, so in my defense.
No, that's cool. That's cool. I mean, I understand. Like, they are working on it. They haven't got there yet. That's an interesting choice to provide a struct with those. I guess it's because they're the most common headers. Because normally what you see, I guess it's probably for performance. for the most common headers, because normally what you see is a string key and then a list of values, because headers are actually array lists. They're actually lists. They're not single values. A lot of people think that they're single values, and they're much nicer when they're just single values. But from the HTTP spec, they are lists.
Yeah, they are occasionally single values, but
They're almost always single values. You will very, very rarely, if ever, see a header that is a list. Like exported for, but that list is built in. But like I'm talking about where you have the same header over and over again.
okay, yeah,
To build up the list.
Yeah.
Most headers that have a list, like exported for, will have the list inline separated by commas or something.
Mhm.
But there are actually some headers that you literally put the same header
Yeah.
multiple times, and that builds up the list. And the way that most frameworks implement that is that winner wins. They either decide that the first or the last header is the winner, and that's just what they give you.
yeah, and the HTTP standard in general is awful, outdated, and extremely difficult to read because the documentation is worse than the standard, even though the standard itself is bad.
Whoa.
You just totally offended AJ.
Like, I agree. We've needed pipelining for a long time. I don't disagree with that. Not having pipelining was very, very 90s thing to do. But, I mean, come on. New lines, colons, it's pretty easy stuff.
Yeah. And in the defense of the HTTP standard, when it was invented by a single guy at CERN who used it just to share documents with his coworkers.
It's always how it starts.
But it's fairly simplistic.
This
If
is
you compare it to like frame relay and other stuff that we had to do before.
I think that HTTP is one of the few standards where, I mean, probably because it wasn't designed by a committee. Well, at least probably not until HTTP 1.1 or whatever, but I actually think HTTP is pretty good. It's got some short-sightedness in terms of, yeah, they didn't know the whole internet was going to be built on it, but if it were made today, it would not be this simple.
The same guy who invented HTTP, as a counterpoint to that and to the point I just made, he was the same guy who coined the term World Wide Web. Like, he did know at some point.
And he did make it extensible. So there's a lot of things that you can put into it that he didn't think of at the time.
And for instance, I mentioned that the body can be encoded a million different ways. That is like that, right?
Sure.
The standard doesn't care how the body is encoded in theory.
I think you're right. I think you can, because you can even encode it in binary, and that's fine, because you can, yeah.
As long as the thing receiving it knows how to deal with the body, your body's fine.
Yeah, because all you need is the length. You need to either know the length or know that it's chunked.
Oh, one more question. Why is JSON the thing they send messages with? Why not like?
Well, that has to do with the popularity of JavaScript and is its own topic. The main competitor is form encoding, which is not better. So by default in HTTP, when you have a web form, it has its own encoding, and that coding predates JSON, and it's not terrible, but it's not better. So
It's not nested. It can't handle lists of values.
Okay, I was just wondering if there was like an information theory that like they optimize how people.
No.
no.
JavaScript is the answer.
Okay.
Definitely not.
You can also use XML, but very few people fortunately do that.
So
That used to be quite common,
Yeah,
though.
SOAP is the worst.
so JSON can almost represent all natural information, right? The only thing that it doesn't do well is it doesn't distinguish between a struct and a map. But if you and it also doesn't distinguish between a tuple
JSON?
and a list. Yes.
There's no distinction in JavaScript between a struct and a map, period. That's why it doesn't distinguish.
Right, but that's what I'm saying, is that JSON can represent almost every natural data structure. Like, if you go out in nature and you look at any form of communication, whether it's cell division or human communication, like, there's patterns of information that always recur, and it's basically key-value pairs, lists, structs, meaning key-value pairs that have a definition to them, tuples, which are lists that have a definition to them. Like, so it can, and you can have, lists and tuples are interchangeable at the dynamic level of it. So you like whether, so example of a tuple would be, if, and actually Zig does this. Zig does tuples and structs the same, because an anonymous struct is the same as a tuple. So a key value pair as a struct would be name, AJ, age, 38, location, Provo. A tuple would be if you omit the key pairs. So you have differing types of data. So AJ is a string, 38 is a number, and then Provo is a string. So that would be a tuple. A struct and a tuple, the only difference is whether you access them by index, 0, 1, 2, or in some languages, 1, 2, 3, or whether you access them by key, name, age, location. And then a map would be something that's arbitrary, where the keys are in of themselves values. So if my ID is AJ, and then someone else's ID is Steve, and somebody else's ID is Janet, then those keys represent some value, and the value is probably a struct. It's probably a structured value, so then or a tuple. But when it comes to data that goes in binary, structs and tuples are the same, because in memory, when you look at the computer's memory, there's no difference between a struct and a tuple. The struct only exists in your editor, and it's for your benefit as a programmer. In memory, everything is essentially tuples and lists.
Yeah, I mean, essentially everything is just numbers with a length and a position.
It's just
Like,
ones and zeros and a big list. That's
Yep.
everything.
So you're building your message, you're designating what the length of your total message is. That's probably a parameter you have to fill, right?
yeah, Zig does handle that part for you.
Okay.
Now, it didn't used to.
And then you're pushing it back to the
Charge? Do you have a USB-C cable? I've got a USB-C charger.
I do. Yes, I have a charger.
Okay.
Could you explain what the rec body is on line 76?
76?
Yeah, so I'm wondering, was that an allocated object, rec body?
Yeah, rec body is, I'm parsing the body of the request into JSON. That rec body is the JSON that I'm getting out.
So do you deallocate that, or do you keep that around? Or like-
I am actually using, you've all flustered me so much I can't remember. Arena. I'm using an arena.
Okay.
So it does get deallocated. I'm not just letting it live, but it doesn't get deallocated in this function.
So is the arena per worker?
The arena is per worker, yes. And then it gets reset after every response goes out.
So you could rename your allocator parameter to just be arena, and people would know, do not pass a different kind of allocator in here. You can pass in your own arena, but
Yeah,
it has to be an arena.
you know, I actually, when I was designing this, I was like, maybe they want to use arenas, maybe they don't. So I actually have a config file, and one of the config parameters is whether you want the server to pass an arena or pass the allocator. And so if you've got a reason you don't want to use an arena, it'll pass in a regular allocator. In hindsight, that was a bad decision, but that was the decision I made.
Wait, why was it bad?
Because it should just always be an arena. I don't know a circumstance in which it's actually better, in my case, to not use an arena. And in my actual site I built with this that I showed, there's no place that doesn't use an arena. It's all arena.
Two more questions. One is, how did you handle, can you go back to routes? Because I wanted to check how you handle dynamic routes?
Do you mean the router? Because these are the routes here, these functions.
Sorry, the router, because I wanted to know how, like, did you ever add in like another, like is colon and
Yeah, so this is a dynamic route. So this has a URL parameter, this endpoint. So in theory, I should be creating a struct or some kind of array to do that, but I'm not doing that. I'm just saying to ignore this parameter. And then in the actual endpoint, because I'm passing in the request, you can then extract that out. And I do have a helper function to extract that out as part of the server library, but I'm not passing those in pre-parsed. And really I should be.
How do you handle state? Or have you gone as far as to have a concept of middleware?
No, I have not gone. When I was building this, I didn't need middleware, so I didn't bother.
Well, have you seen that? Like I haven't seen it. Do you know what the general way to handle the middleware type of thing, or to basically to keep state in between? Could I add? How would I add state to? Does the request have a way to add state to it without wrapping it with something else that would then make it incompatible with another library?
So you would have to wrap the request to have middleware. So you could just have the callback go to some middleware that would then route it for you, and you could reuse the same routing functions to route it separately. Alternatively, you could edit the actual library to just support middleware. You could allow registering middleware and then give it some kind of mutable object with known values that you can then adjust as it goes through the middleware, and then finally give it to that callback, which is what I would probably do if I was going to do that.
So you would create an object that contains the request that then contains the state values?
Correct.
Okay.
Are you plugged in right now? Your power's going down.
Still, yeah.
I
Let's see. Oh, you know what? I think this may have been turned off somehow. It was on, but it's not on now. Okay, now it's on again. I see the red light again. I didn't see the red light just a second.
I have another charger.
Is it still on?
I saw the red light before you.
Are you
pressed
still
the button.
recording?
Yeah, it's still recording.
I didn't know if you just turned off your recording.
Oh, well, this is plugged into the computer. So the
Okay.
computer's providing all of the power.
Now we're charging.
So where did you get your inspiration from this? Like, were you looking at web servers in different languages, or were you using some of the stuff that's already been written, or?
Yeah, so speaking of watching the Primogen, he mentioned in one video that you should make something from scratch one time so you never have to do it again. And so I made a web server in Zig, and I was like, you know what, that actually wasn't bad. It works really well. And then after a few updates came, there was a workable standard HTTP library. I was like, I bet I could do it better. And so I have worked, like I said, I do web development. I have worked with a lot of different servers. And so I did look specifically at what I didn't like from other servers.
Ooh, let us know.
Like, so there's a couple of frameworks. I think one is Zag. What's the other one?
So-
there's Mookham's IOU
Tokamak?
server.
Yeah, Tokamak.
Yeah, so I have looked at those. I haven't ever used one, but I have looked at them. What I don't like about a lot of the ones I have looked at is that they do use C libraries, and I'm just morally opposed to the C runtime, so.
Tokamak just switched.
Yeah.
Did it?
Tokamak just switched to Inherent Zig, probably because they just released this, right? I think they switched.
This was like 2 weeks ago, yeah.
Yeah.
I haven't looked at it in the last.
And the one
Couple
I'm
months.
mentioning, one like the
But-
SPA competition, wherever GCC, like the previous fastest web server was a Go server for single static pages. And then this guy just translated the Go code to Zig.
Yeah, so going back to earlier in the talk, though, a lot of these frameworks, even if they're better than mine, which They almost certainly are. They're going to make different technical decisions than I would make. So even if they're better for everyone, they're not necessarily going to be better for me.
It's features. So like when I was doing Python web servers, you kind of pick your framework and you have to go with your framework. Like you pick pylons, you're a pylons guy. With Go, you know, you had Gorilla early on. This is before Go had their internal stuff. But you could kind of add on whatever you wanted as long as you knew what to include and stuff. So it's kind of more of a heterogeneous environment. It's probably kind of the same thing. I mean, you can put Nginx in front of this to handle a lot
Oh,
of
I do actually on my personal website that I showed, which is actually running my older server. I haven't updated it to this one yet. It is Nginx in front of it to handle some of the security stuff.
That's right.
And realistically, Nginx isn't going to provide that much slowdown or...
Right.
What kind of security stuff do you need? I really don't know.
Well, if you want to,
So, it depends on your use case. So in some use cases, absolutely none, realistically.
I
But
just want to know what consideration you made for your website that you just showed us.
what considerations?
Yeah, for security that you chose, why Nginx or why?
You know, I had a reason at the time, and I do remember it was security based, but I would be lying if I told you I remembered what it was.
Nginx handles some core stuff and some other things, so that you don't have to check it. It can also do some load balancing stuff if you wanted to.
It also, there are some security issues with opening a public port, and there are some things you can do if the port is not tightly secured enough. And Nginx, when it takes a port, I do know that there is a lot of back-end security for what it'll filter out of requests, which is more secure than just opening your port directly.
I'm just curious, like, what does it do?
What-
Does anyone know?
What?
What does it actually check? Like, what does it actually do?
So if you just have a server, you can try to hit any port that you want to. In fact, that's how people kind of break in. They see how naive or whatnot your server is. So they'll just go and hit whatever port to see which port's open, which port they can get a response to. So Nginx will actually filter that down into specific ports that it'll transmit. You know, it just dumps
That-
anything.
And-
not
That's,
in.
I don't believe that's the case. So
I don't think so.
So, okay. The way that ports work is they're closed by default.
Right.
So if you just start up a Linux server and it's a cloud image, it will start with no ports accessible to the internet. And that's not because of the firewall, that's because there is no internet software running on it. So it will, if you try to go to port 80 on the server, the kernel will reply with a rejection message because it doesn't have anywhere that it can put that. If you put a firewall up, which is at the kernel layer, typically what a firewall does is rather than sending a rejection message, it will drop the packet. So if you don't have a firewall, then the kernel will reply, no, that port's not open. If you have a firewall, the kernel will, which the kernel is the firewall, it's a module of the kernel, but then the typical configuration for a firewall is that it will not reply that the port isn't open. So you won't know whether you're experiencing a network delay, a timeout, or if you are hitting a firewall. When something binds,
And that's a feature.
that's a feature. That's because the idea is security by obscurity. That if you get back, this port is closed, then you know that there's a host at that IP address. So if I just start pinging the internet, whatever I get a reply, invalid message back from, I don't need to get the pong. The ping was successful in that I got a reply that rejected. I got a reply that
So-
the ping was rejected.
Some things that I do know that Nginx will handle for
Sorry,
you.
were in the
That
middle of a different statement before, if you wanted to finish that.
no, that's okay. But some things Nginx I know does handle is you can rate limit requests from a single user, which can help with bot attacks. You can also by default, all HTTP requests go to a single port, but you cannot realistically have a bunch of things listening at the same port. So if you want to have multiple services running on the same server, you need to have a reverse proxy, which will listen to that one request and then dispatch it to the proper server. And you can't do that without a reverse proxy, essentially. And Nginx, that's its primary purpose is you can have multiple servers running on the same machine and it'll dispatch to where you want it to go. But again, it can also do rate limiting.
I say from a security standpoint, the other thing that Nginx is going to parse a request. Like,
Yes.
depending on how mature the standard library here is, how mature your parsing code is, people can just hit arbitrary bytes at it and see if something breaks it. Whereas to get through Nginx, it's going to at least have to be a valid HTTP request.
And there's also a wrong reason to use Nginx, and that's because it has a PHP engine. So
That's
Well, I mean,
the opposite.
that's just a standard feature of web servers these days.
So I'm just wondering, like, how big of a library are we talking about to replace Nginx?
Oh, massive.
Like,
Nginx realistically does too many things, and I use Nginx at work. I haven't used like 100th of the features it uses, which is why I'm not
Well,
able.
Then you could have 100th of the code, right? So I'm wondering, like, how much of Nginx do you need that we could replace? I'm not saying like how to.
Are we about to
Rewrite.
do
all
Yeah.
you need,
Let's do a project for next week.
all you
Yeah.
need is to know what you want your headers, so you need a limit on what your path size is. So how many characters could be in the URL? Generally speaking, I don't remember exactly, but generally speaking, the industry standard is 4K. So you couldn't send a file in URL. You need to have, again, a limit on each header, how big a header can be. So industry standard, again, I believe is 4K. And headers are typically under 200 bytes. They're typically under 100 bytes. So you need something that can parse the new line. Forgivingly, it should be able to accept a new line, a carriage return, or a carriage return new line.
No, in the HTTP standard specifically, it actually is supposed to be
It's supposed to be a carriage return new line,
carriage return new line, yeah.
but,
We should go to AJ's shed and we should rewrite or replace Nginx.
well, we don't, sure, but we don't need to. But you need to make sure that you don't overrun your buffer. That's number one. That's the number one problem with security in web servers. Overrunning the buffer on the path or a header. You get to the new line. The reason that you accept either is because software today is, yes, the standard says carriage return new line, but the way that it's implemented is any of the three because reasons. And because you want to be able to use it from like Telnet and Netcat and stuff like that. But
Your typewriter.
Sorry, what
that's
is Telnet and Netcat?
Don't.
they're debugging tools. They're low-level TCP debugging tools. And then you handle a double, let's call it a new line, but whatever separator it is, a double new line, that begins the body. There's a content length, and you need to make sure that you've either read the content length, and you only read the body to the content length, or it'll say chunked encoding, in which case the first line of the content will be a number of how large the chunk is, and you read until the end of the chunk. Then you need to protect against slow loris attacks, which is where someone sends a byte, say, every 1 minute in order to keep a connection alive. So they just open up 10,000 requests to your web server, and then on every request they just send 1 byte at a time. So there's the slow loris attack. And then there are HTTP2 attacks, which is where you provide both HTTP1 and HTTP2 headers. Nginx mitigates this problem, but there's a way to get the server to basically accept the wrong header and then perform a request, say for example, on an internal administration resource, rather than the resource you were actually authenticated against. And there's the same type of attack in the TLS stack as well, with server name indication and host name.
So, I'm a big proponent of rewriting things yourself and not relying on other people's stuff. But I would say that realistically you only have a limited amount of time and you have to pick your battles. And the slowdown you are going to get from Engine X is minuscule. It's extremely fast and it does its job really well. I would say if you're going to choose between replacing your actual server or replacing your reverse proxy, the reverse proxy is a much lower priority in my mind.
One more question. How many other practical barriers are there aside from the reverse proxy, writing your server, and getting this code onto the web?
If you're on AWS, there's about 20.
Listen, I don't handle that side.
So, I mean, realistically, if you're running a bare metal machine, you've got your firewall, you've got Nginx, and you've got your server, and that's about it.
And if you're using a cloud image, you don't need a firewall. Unless you're actually doing weird stuff. Like if you are running this web server, you don't have to configure a firewall because there will be exactly 0 ports open until it binds to the port.
Yeah, so realistically, your reverse proxy and the server, but the reverse proxy is going to take a lot of time to rewrite, and the actual benefit thereof is negligible.
And once the standard
Plus-
library hits, you wouldn't need Nginx for this. Like I agree, like there's a lot of benefit Nginx gives, but by the time Zig hits 1.0, I don't think you would need Nginx for a Zig project any more than you would for a Go project or a Rust project.
Now, if you are using Python, however,
Oh, yes, you must.
this is what you need to run a Python web server. You need a reverse proxy, not optional.
Yeah, you must
With
have.
this, it's technically optional, and there's not a big security risk if you don't have one. And you could also just do some of the rate limiting and stuff yourself if you wanted that specific thing. But with Python, you need a reverse proxy. You need then a WSGI interface, which is generally going to be either Junicorn or it's like Uvicorn. They both have unicorn-like names. And then you need whatever framework, because the standard HTTP library on Python is not sufficient for actually writing a web server. You'd have to write something like this or use a framework, even in Python. And so, wait, sorry, I skipped. There's also WSGI. So there's the WSGI interface, then there's WSGI, then there's whatever framework you're using, and then there's your actual logic.
Most people, when they're talking about Python apps, they just say Django or
Yeah, so Django sets up a lot of that stuff for you, but it's still there. And then if you're using something like Flask, you have to set up all those things. And it's somewhat similar if you're using Node. It's not as bad, but there are still a lot more layers before you actually get to your real logic than you get with something like this or writing it in Go.
Yeah, if Python is the reason Docker was invented. Because but that's the truth, right? Like it was invented because of Python and Ruby and systems that are like that, where version numbers that are a tiny bit different can completely cause havoc on your system. And so in order to install the 10 different layers of tools that you have to install, you need something that's configured and that won't update.
Yeah, but I don't know if Zig solves that update issue, or maybe we haven't reached 1.0 yet. So
We haven't reached 1.0, but the thing is, even if it's just as bad as Python or JavaScript or Ruby, heaven forbid, with breaking changes, that's still only one surface. With Python, like I said, you need to have like 5 services just to run a web server, and every single one of them is going to be susceptible to those changes. And you end up with these problems in Python. You frequently have to run code versions that are 3-4 years old because you have to use X version that of this software, which works with Y version of this other software, because they've all got this new version from 3 weeks ago, but that doesn't work with any of the other versions from 3 weeks ago, so you have to run 5-year-old software just to get it to work, and Ruby's even worse.
With Zig, if you compile a static binary, like a Go, you can have 10 different pieces of code that have 10 different environments that you can build them, and they're just 10 binaries, you stick them on the same server and they're fine. If you're doing something Python, you need at least a virtual environment to keep their libraries separate, for each project, but that only works if you aren't using any system libraries, because Lord knows I found the library I was trying to use recently depended on a version of OpenSSL, which is so old I couldn't find it. I'm sure it's out there, but I wasn't about to get it installed on my computer, is really what it came down to, just to link with this student Python library. So that's where things like Docker break, because you can have a Docker image with, CentOS 6 and, build whatever you want on there and run it with whatever libraries you need, but it keeps it separate from the rest of your system.
So I work with educational software, right? And Canvas is like the big name in Utah. And they Dockerize everything, but if you try to run your own version of Canvas, you essentially can't. Because even though everything's Dockerized, the build scripts to build the Docker images are all using mutually incompatible, outdated software. And it's written into like 10 different microservices.
You're the reason I had to use that app.
So
I had a lot of trouble.
I will be the first person to admit essentially any framework you find will be better written than what I've written here. But I don't think that means they're better. Honestly, I would argue something like this is better for most cases in the long run than running Python or running Ruby. Those aren't the only choices, but realistically writing it yourself, if there are trade-offs, you get to decide what those trade-offs are. If there is something that breaks, you get to decide how it's fixed. You're not waiting a year or using a 3-year-old version of the software so that it still runs.
I think this is cool. I really appreciate you showing us this.
Yeah.
This is
Thanks for showing us this, because this is outside my.
100%.
There's a lot about this.
And sorry, did you say earlier, do you have the repo for this?
Yeah, it's a public repo. So
What is it?
it's if you go to my GitHub, which is just Andrew Gossage, or then it's called Zoi, Z-O-I, which is the Greek word for life, because I feel alive when I write Zig.
I just need to make sure my code is clean and real. It's not like chaos.
And there's some bad choices I made, but again, the great thing so the intention of this specifically is not necessarily to have a library that you import. It's essentially like, if you wanted to use this, it's essentially a starting point where you take it and then you rewrite the parts you don't like, and it's meant to be easy enough to just do that.
Oh, I got one more question. So we talked about Svelte at the start of this, and I understand you laid out the limitations of Svelte. That's why you need to move to a different style.
Well, we moved from Svelte 4 to Svelte 5, and it was the router that was broken, but yeah. I like Svelte, kind of.
Because I just know from Theo that Svelte rules and the ability to work either on the client or the server side was like one of its advantages compared to other frameworks, and it gave you that flexibility.
Yeah.
And I want to ask, would you have to hand implement that in Zig, or is that provided?
So if you wanted to do that in Zig, you would have to use WASM,
Okay.
and I am morally opposed to WASM.
Okay.
As you should be.
There are three. I've said this at 3 other talks I've given, but there's 3 types of people in this world. There's people who want JavaScript or on the back end, people who want Rust on the front end, and people who actually know what they're doing.
Agreed.
Yeah, I use real assembly, not WebAssembly.
Okay, but all right, there actually, I think there is a valid use case for WASM. I want to hear your take on this. Okay, so in Go, you cannot have, well, I mean, in dynamically compiled languages in general, you can't dynamically load features except through dynamic linking, and Go doesn't have that. So there are some things that are compiled into WASM. They can even be Go compiled into WASM, so that it provides an interface to load something in dynamically and be able to use it, but from another language. So if you wanted to extend something hot while it's running, you could do that. But I guess maybe that problem's already solved by dynamic linking.
So
in the first place.
you can also solve that same problem by just using a scripting language like Lua.
But
with-
then you have to be using Lua, whereas with WASM, I could take something that you've written in Rust, and I can run it. Like the number of people that are not game developers that use Lua is
Small.
Tim Caswell.
Lua is like a subset of JavaScript almost. Like it's so small. I mean,
Lua is also much faster than JavaScript. So I agree. There is this one database, I don't remember what it's called, but they're essentially entirely stored procedure based, but their stored procedures are WASM. And I think that does make sense, because essentially they want a virtual machine like you get with Java, but they don't want to use Java.
Exactly. You get the Java bytecode without the Java.
The problem with WebAssembly isn't compiling to a virtual machine in and of itself. The problem with WebAssembly is the web part of WebAssembly.
Yeah, uh-huh.
So WebAssembly, for instance, cannot interact with the DOM. So in order to interact with the DOM, at least this was true a while ago.
No, it's terrible for the web. It's meant for servers.
Yeah, except it's not, like, it was made for the web.
I know, but the irony is, yes,
Yeah.
I would never recommend running WASM on the client side unless you were maybe Figma, because I think they're the only application I've ever seen that needed it.
Yeah, Figma also runs everything in a canvas, which...
So maybe they made some other poor choices and they're compensating. I don't know.
Yeah, so that's my problem. It can't interact with the DOM, so anything that actually affects what the user sees and interacts with has to be in JavaScript anyway. So it doesn't make a lot of sense to introduce an entire new programming language to do, like, your math calculations.
Well, unless it's a game.
Unless it's very visual based.
Yeah, I mean, I'm not saying there are no use cases where it makes sense, but I would
Are you
say...
sure? Because I think you did say that.
I said I'm morally opposed to it. It's against my religion.
No, and even as I think about it in the Go use case, it's still...
And Go, you can't even use regular Go last I knew. You had to use TinyGo for WASM. Has that changed?
No. I don't know. You never had to use TinyGo for WASM as far as I'm aware. I mean, maybe I'm wrong. I don't know. I haven't used it, but this is what I would say. You're probably better off just having a microservice. Just having it call
Because
out, make a request to do what it needs to do in the other language.
My understanding is that WASM is not very good with garbage collection, and so to get Go to play nicely in WASM, people maybe sometimes use TinyGo.
A pending version of
That would make
the
sense.
WASM spec has support for different forms of threading models, but right now it has no support, so you can't actually run like the Go runtime properly and the full Go runtime properly in WASM.
Vindicated.
Okay.
So TinyGo is sort of the standard way if you wanted to, I think you can compile normal Go to WASM, but I think you just don't ever get garbage collection. You know, it's like...
It's the same thing with Python.
Things don't work right.
Well, I think my understanding was that you just get a huge freaking binary, and then you have competing GC pauses because you're running a garbage collector and a garbage collector, so it's like.
I do know with Python, I used to be a Python developer. I've repented, but
Welcome to the fold.
thank you. The Python, essentially regular Python, just does not run WASM. You have to use this fork of Python that, again, is like 5 years old.
Huh? They don't. I would have figured they would. I would figure there'd be like a libwasm. I don't program in C or use C languages, but I would imagine there'd be like a libwasm. You just import libwasm and FFI that easy.
I mean, you can't. Rust has something like that, but not Python.
Okay. All right.
Python's got a super heavy garbage collector and super heavy backend. It just doesn't work with the way memory is allocated in WASM.
Well, you can run Doom in TypeScript types. And
Yeah, but it's like one frame every 2 days.
Yeah.
Well, that depends on whether you're using the compiled version or the interpreted version. Because there is a compiled version now. Because when they did the interpreted version, the other person took that as a challenge and solved it.
Yeah. And TypeScript's being rewritten in Go, and so you might be able to run it way faster.
The TypeScript type compiler.
Yeah, and the TypeScript type Doom, I believe that it's actually implemented on a WASM implemented in TypeScript types too.
Oh,
So
wow.
it's like Doom.
And it
on
works with like
on TypeScript.
I
So it takes 2 days to render one.
At least it should compile fast.
So, did you have anything else that you wanted to share in your 8-minute presentation?
There's like 2 more slides, isn't there?
yeah, and I also wanted to go with how I also wanted to show my templating library, and
What, you got a templating library?
I do have a templating library,
What?
a super basic one, but yeah. But I think,
Super advanced one. That's what
but I think we might have to wait for another time.
Doesn't standard format print just basically handle templating?
No, absolutely not.
Because you could just make any string you want out of that, right?
I mean, sure, but if you want to import an HTML file and then fill in variables, it's not going to do that.
Yes.
The format string has to be compiled, right?
Yeah.
So you.
Well,
And you
it
can
is-
get past some of that imitation with inlining,
Exactly. Yeah.
but for templating, you need a little bit more than that can do.
It is 9:30, so I do want to push us towards the end of the presentation so that we can continue the conversation outside in the 100-degree
Yeah,
night.
let's end now, and then I can maybe talk about it more another time.
But I need to see the rest. We need to at least, I mean, are you just going to keep it a secret until next month?
Yeah.
Sure, but
This was great, thank you.
Yeah, what are we doing
At
next
least
month?
show us the slides.
Robert was going to do something.
there's
so-
not that much on the other
We went
slides.
to the end slide anyway. We're missing the second to last.
And then I think you were going to give a presentation the month after on all the company secrets that you've discovered?
No.
Oh, no. So,
I
can
think that's
do-
how to build an LLM.
Because you missed February, I can do a remap of where my game is now.
yeah?
Yeah.
Okay.
Cool.
I broke it before the February presentation, but it works now. So I can show an update, and I'm pretty proud.
Thanks.
It was still a good presentation.
Put them on the schedule.
All right, hold on. I'm getting into the chat above. Okay, so we got Andrew. The last 3 minutes of Zick. Schedule 90 minutes. And then remind me your name. Brian. All right, Brian.
And a non-broken video game demonstration.
Non-broken video game demo. Warning, AJ will be present. And wait, how do I get in touch with you?
What? No, and then, but I can make it multiplayer. And then, I can give you my email or phone number.
Okay, text me real quick,
Okay.
because my phone's...
We're still live, right?
Oh wait, we're still live. I'll give out my phone number after we're not live. Thank you. I appreciate that.
You can probably just end the stream.
Yeah, I can end the stream. We're done. Okay, so let's give a big round of applause to Andrew. Even though he only gave the first 5 minutes of his 8-minute presentation.
I love at the start of this, we said that the presentation was over, but by the end, we never got to it.
I don't know what happens. Does he get the girl? You did have the child,
Yeah,
right?
and it's my fourth one, so
He got the girl. All right, let me think. Where's the stop button here? And to those of you tuning in online, we collectively apologize, I first and foremost, for our misbehavior, and you're welcome to come again.